But I feel like if you're not doing shit like you want to go by slow, like, but if you're getting lecture, you know, shit like that, talking, especially with his personality, bro, it's just go by pretty fast. And then we're done by July 3rd. I'm done with math for the rest of the
You can really celebrate the fourth, right? That's what I like about it. All right.
Because this one goes to others. Right. You want to see this? Yeah. I'm really boring in school. I thought this was your exciting. Oh, no.
There's no way.
I know, right? Can I borrow some of your why you wanted to stats?
You guys with me? If you wanna, I'm gonna start to do this. I think everybody got 4. Please, dear God, don't force yourself to use this. You could. Why would you? So if you ever get a decimal, you round up to the next whole one. That's fine. There I can see it. Whenever I do these, I am going to pick to do this because most of the time people choose this way. If you did it the other way, you can always ask me what it should look like. And then you guys, the frequency here was 2. Is that right? Yes.
Do you want us to write on the classes like you want us to write the lesson that equal to say?
Okay.
Or is it okay with
You ready? You guys. Everybody. So this first class, you either write it like this, which means on my histogram I have to go up and down by 0.5. You can't do half and half. Or I write this first class like this, and these numbers don't change. Because still, where's the 65 go? 65 still goes in the second class, because that's where it's allowed to equal 65. You guys see that? So either you do this way, which requires up and down by a half, or you do this way, which doesn't need the up and down by half, but it requires you to be cool with inequalities and x's and shit. Which you really should be, but I'm not going to judge you if you're not. At least not in this context. Okay. You guys good with that? You guys all right? Okay. How do I get the relative frequency then? So no matter which way you did it, your number should have come out to be this, right? And thank God these added to be what? Yay, so I didn't miss anybody. I love it when people add up and they get 32 and they just keep going. I'm like, that should be an issue for you. You should stop. So what's this?
2 divided by 35.
Which comes out to be roughly 5.7. 11 out of 35. 31.4. What was that? 37.7? 37.1? 7 out of 35.
Only 20%.
Yeah, 1/5. That's a nice one. And then 2 out of 35. I know that one already. Yay. And then cumulative frequency would be 5.7 so far. Add that. Right? Add that. That's neat. Doubles. Add that. And then add that. I get really close as we round it a bit. How's everybody doing? So if you didn't round as much as I did, you should have gotten a lot closer to 100%. If you're rounding more than I did, stop doing that. Set out to one place, at least when I'm doing it by hand. Okay, I like it, I like it. Everybody good? And then here I said relative frequency, so you gotta be really careful about what I ask. I'm trying not to be tricky, but you just got to pay attention to what kind of thing I want. So I want these to show up on my scale, so I need to be able to make it up to this. So I think most of you guys used 5, 10, 15, 20, 25, 30. I did bad. I did horribly bad. I did a bad job. Try again. See, this is another reason why you should use pencil. So 5, 10, 15, 20, 25, 30, 35, 40. That's still really bad, but you got. All right. Let's see if I can Frankenstein this bad boy. Whoa. All right. Zoom out a little bit. Yeah. All right, this is going to be rel freak. Label that bad boy. And then this scale, it's not labels, it's a scale of numbers. So since I chose the textbook way, I've got to start where? 60.5. And then I just keep adding 4 because that was my width. And how tall is this first bar going to be? A little bit over 5. I like it. The next bar is going to be way up to 31. And then up to 37. And then where am I at? 20. And then back down to just under 6. Let me ask you this. How many of you guys know the phrase bell curve? Anybody? Bell curve, okay. Does this roughly follow, really roughly, does it follow a bell curve? Low, high, low. This bar is the one, if it was this way, then it would be like really a bell curve. And another name for bell curve, the one we're going to use in this class, it's a normal distribution. Why do we use the word normal? Heights are normally distributed. If you follow the genetic makeup of a human, what normally should happen is very few people down here, then a lot of people in the middle, and then very few people way the hell up here. Like, anybody know Manute Bowl? You ever heard of Manute Bowl? I actually saw him come off a Southwest flight. I saw him come off. There's a crowd of people. You could just see Manute's head. He was 7'7", right? So yeah, so that's not normal. And I'm not saying something's wrong with him. I'm just saying you would do a double take if you saw that for damn sure, right? You're like, what? So that's all that normal means, is that this very much describes natural processes. And most of the things are going to be in here and very few things out here. You got Tyrion Lannister down here, right? Any Game of Thrones people know? And then you got Manute Bowl up here, and then you got the rest of us in there. Okay. All right. So that's roughly normal, I would say. What's down here? What's up? There? Is that all right? Okay. So what should be down here? Good. Fathers. Heights. And it didn't say, but it should be inches. Hopefully you understand that's not feet. Some big ass people. Yes? All right?
Yeah, sorry, I just had a question. So for the running girls side, we didn't use those, we was just like, yeah, we just use the frequency. Is that okay?
What did they ask for, though? So your picture, is the shape the same? Yeah, totally. Of course the shape's the same. It's just, if I divide these numbers, the numbers you use by 35, then you get different labels here, right? So when I say make a relative frequency histogram, I want these to be the labels here. I want the percentages to show up here, not the pure numbers. Yeah.
So, we did that, like, we still labeled 61, 65, 69, 73, so on the graph, that'd be right.
That would be wrong. You would lose points. You've chosen a way. You can't, in the middle of a problem, choose another way. And you're like, I did. But I'm like, I'll take points off. So if you choose to do the book method, you've got to use the boundaries. like that. What would this have to look like if you didn't want to use the boundary shit? It's got to look like this. So if you don't like this, there's give and take, right?
So for classes, we have to write it like that if we don't use the boundary.
Yeah, if you want to use 61, so if I use these classes, this would look like 61, 65, 69.
So we just have to write the X or
Yeah,
sorry.
and the inequalities and everything's got to be right. Okay. Yes.
Do you care if we, like, for units, for like the relative frequency, we put like percent, or no? You don't really care. Like it's in a percent instead
Oh.
of like a number, just regular number. Like say we were to write for like the axis, like relative frequency, and then like parentheses in a percent, like the percent sign.
Oh, like this?
Yeah. Does that matter? Because I know
I don't
some
care.
teachers care.
That's fine.
No. Okay.
Yep. I want you to realize something. To a math person, 0.487 is the same as 48.7%. They both are
Yeah.
the same.
Mhm.
Two
That's
ways of representing the same number.
Because like 5.7 as a number is not the same as like 5.7%.
Exactly.
So
I like it.
that's why.
Yeah, you're fine. Yeah. Okay, okay. All right, got a whole other side to do. Oh, people got too used to my time yesterday. What? Oh. All right, this first one should have been pretty easy, right? Does anybody have questions on that one? Can I just not do it? I want to get further in my lecture, so I'm trying to. Was the first one any problem? No. Okay. This one, I think I got around to everybody about this. So when you write this, it's understood to be 40 to 49. So we don't want to do that because if you just have too long list of data, it doesn't really show you anything visually interesting. It's almost like just writing all the data out. It doesn't help. So what I want to do, why do I have to do this shit for this problem? Because the data is really tight. It's not very spread out. So I gotta break things up to be able to see it better. Do you guys understand? We're gonna learn a number, how to calculate a number that tells me how spread out data is. So the less spread out it is, the smaller steps I want to take. And the more spread out it is, the big ass steps I want to take, right? So this number we're gonna learn, I'm gonna reference it as steps, but it's officially known as standard deviation. So it tells you the spread of data. This is not very spread out. So I want to take smaller steps. So I want to break this up better. So this will be like, do I have a 4 blah 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 up to 4 right? And this will be 4 5 blah 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 up to 4 9. You guys with me? I'm not showing you, just writing down numbers. I think you can do that. And this will be 5 out of 5 4 5 5 to 5 9. You just write all the ones. So there's 5 5, no other 5 5s, right? And then 5 6, 5 7. There's a 5 7. Is everybody with me?
Yeah.
Yes.
So if this was like on a test, and you said you didn't say anything about making a better like setup, and you just gave us the data to make like a 7-leaf plot, would it be like an unsettable to like break it up, or would you?
Yeah, and that's why I'm not going to necessarily do that to you, because it'd be a little evil, but I want you to realize a little more about the flexibility. So this problem, I wanted to give it to you, because then I can talk about stem and leaf in a more fleshed out way, but after you've had a chance to think about it yourself. So when I said 4.0 to 4.9, some of you guys had already gotten there yourself. That was so kick-ass cool. If you didn't, it doesn't matter. This shit's all new. Who knows what's going to kick in or not, right? I just want you to be aware of some of the flexibility. Am I going to do this to you in a test? More than likely not, because you got a lot of other shit to worry about, and I don't want to throw some screwball at you that's not like most of what you've seen. But I want you to at least see this once, in a very controlled, non-graded atmosphere at the moment, right? Yeah.
Yeah.
Is everybody all right? Stay with me. I spoiled you guys yesterday. You're all like, you're out of here by this time. That was yesterday. So this one, the first thing I helped a few people out. How far does this go?
11.
Good. All right. I didn't mean for that to be a trick, but it just turned out to be true. So how many total people were there?
22.
Yeah. If you add up all the heights, that's how many people were in each class. You get 20 total consumers. real quick. What sex is this person? More than like
Male.
Male.
Yeah, okay. How many classes are there? Six. Or it could be like a gigantic bottle of champagne. So there's 1, 2, 3, 4 classes with people in it, 1, 2 without. 6 classes. Total. How wide is each class? 20. So there's 1, 2, 3. There's an empty one. There's another empty one, and there's one there. That's 6. You guys with me?
Is it okay to use class with, because that's what we did, and we got 2.
You got 2 what?
Like, we got 1.6 in rounds 2. We used the class with thing where you take the,
range, and then you divide the range by number of classes.
yeah.
Sure. 120 divided by 6, though, is 20. I'm not sure what you did. What's the range? 120 divided by 6 classes is 20. So that's kind of like a check. Why do you not have to really do that work? Because I can just see. They already did the work. I can just see what they did. But if you want to do the work, sure, that's a way to kind of double check yourself. Is everybody with me? Okay, a few of you guys. I'm curious how many people are going to show up tomorrow. What percentage of the sample does a bottle of shampoo last at least 40 weeks? So how many people does it last at least 40 weeks? 3 out of, that sounds so familiar. We had that percentage yesterday.
We had to get
That was 2.
What are you talking about? All right, at least 40 weeks. At least 40 weeks. So it's these people and that guy.
Oh.
3 people. What's wrong with you? What's at least 40 mean? 40 or more? How many people had it 40 or more? 3. Okay, I like it. Don't see 40 and just go here and go, okay. At least 40. I like this. Okay. What's up? So here's 40. How many are above 40? 2 and 1. So 3 total.
So empty classes count?
Yes, because you just said it. You just said it. Empty classes. They're classes. Why wouldn't you count them? If I said how many classrooms I had, well, that has no people in it. We're not going to count them. It's still a classroom. Holy shit. Yeah. Okay. I like it. All right. I am going to do a little more. Too bad. You guys can reorient yourself if you want to. Were there any questions on that? I'm going to see if I can make you hate me.
The width, it's just pretty much the range, or like it goes from 0 to 20, so that's the width.
Yeah, you can see, you can identify the classes by the rectangles. And then the width really is just the width of the rectangle. It's 20. Yeah. Did they use my way or the textbook way to make your classes?
Your way.
My way. Ah. We're going to do a little bit of the next section, which I think is the percentiles. Talking out my ass. It might be the mean and stuff. Yeah, percentiles. Yep. All right. Okay, has anybody ever heard of percentiles? Has anybody taken the SAT? A couple of you guys. When you got your results, I don't know if they still do this, because it's been like a couple of years since I took an SAT. Maybe like 20 something. Huh?
The percentile, like you're in the 10th.
Okay, they still do. It makes, so this is a better way than a grade, really, to figure out your relative position in some sequence of data. So if you got in the 80th percentile, the symbol we use to represent this sounds like a new fitness craze, but it is P80. So this means the 80th percentile. So P17 would be the 17th percentile. So what's your gut tell you? If you are in the 80th percentile, is that a decent place to be for SAT? Yeah. What's it mean though? Did you get 80% of the questions right?
It's not 20%.
Not necessarily. Yeah, you're in the top 20%. Directly, this means your score was higher than 80% of everybody else who took that test. Now, why do they want to use this kind of thing? Because what happens every time there's another SAT test given? It is a different test, right? So there's no chance that somebody can bring information. Every time they change the test, couldn't they randomly make a harder test? And then everybody's going to do a little worse. So your relative position will be the same. So if you take a harder test, you could still end up in the 80th percentile because everybody did a little worse then, if it was a little bit harder. Are you guys understanding? So this is a more fair way to show where you are in a group, right? And that's an example of where you definitely want to use this way, so that it doesn't matter what they've done to the test, everybody kind of rises and falls. Can't like it, maybe. So we got to figure out. So for example, let me say this, because this is kind of like what the homework does. If you were in the 90th percentile of bowling scores, what exactly does that mean?
90% better, or your scores are higher than 90%.
Yes, you got to tell me exactly what it means. It means your bowling score was better, was higher than 90% of other people's. Are you with me? Now, I could have said this. Can anybody tell me why this is a little bit more evil? You're in the 90th percentile golf score.
Because it's backwards. Like high is bad.
High is bad, because then 90% of the people scored higher than you, right? So if you don't play golf, I'm not going to do that to you. The score in golf is how many strokes it took, and the less strokes, the better you are at golf, right? So it's kind of reverse. So if you're doing a race, do you want a fast time or a slow time? Let me say that again. Do you want a long time or a small time to complete the race? Small. So you want to be like, if you're P10, if you're in the 10th percentile of times in a race, is that good or bad?
Good.
Think about it. If you're in the 10th percentile, you're right. If you're in the 10th percentile of times in a race, only 10% did the race faster than you in less time. Are you guys with me? Stay with me. So percentiles never change their meaning. If I'm in the 10th percentile, 10% of everybody else did less than me. Golf and bowling is an example of where slower scores mean one thing in one and another thing in the other. Are you guys kind of with me? Are you? Not at all. So what does 20th percentile mean, period, for anything? If you're in the 20th percentile, what does it mean? 20% of people scored lower than you. You with me? Always, no matter what. So if it's time in a race, that's a good place to be. Only 20% raced faster than you, because only 20% had smaller times than you. Right? So percentiles always mean the same thing. That percentage was below your score. I'm just trying to point out that certain things lower is better and certain things lower is worse. You just got to be careful when you get a problem, I don't know, in the homework, where you got to stop and think, what's better in this case? I'm sorry, you got to think sometimes. Okay? But the percentile idea itself never changes. P80 will always mean 80% of it was below this.
So if you were in the first percentile, was that really great or really bad?
And again, it depends. Are you playing golf or are you bowling? Bowling. And you scored what?
In the first percentile.
First percentile bowling would suck. That would be me. Everything was a gutter except the one that kind of like popped out. So if you're in the first percentile, only 1% of everybody else did worse than you, scored less than you did. So in bowling, that's bad. In golf, that's amazing, right? That means you're like amazing. Tiger Woods maybe a little bit nowadays. He's sort of came back a little bit.
He won the Masters.
I know, but let's see if it keeps going.
How will you for sure know that it's going to be good or bad?
It depends on. I'm never going to be your problem where it's not like golf. If you've never played golf, you might not even know how it works, right? So I'm not going to give you a golf problem, but I could give you time to run a race or speed, right? So if you're P20, 20 percentile in speed for a race, is that good or bad? Why? Because only
It's only 20% below.
20% were going slower than you. So you're going pretty slow relatively, right? Do you understand? So I'm going to give you a situation like that where you should be able to figure it out. If I give you golf, that means you have to know golf, and it's not a prerequisite for this course that you've watched golf at some point. Thank the gods. Right? Yeah, you're just going to hit the ball. Oh, sorry. I personally don't like watching golf. And the ball's been hit. Oh, sorry. So, the last thing we're going to do is I want to do a very specific example. Smaller samples get a little bit freaky, but I have to start small so we get the idea. Just want to say that in the beginning. So I'm going to give us 10 numbers. I'm not keeping track. Where am I at? Let's see. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So there's 10 data points. I've already put them in order. These have to be in order for this to make sense. If I want to figure out how many's below something, they have to be in order. Does that make sense? Thank you. Can somebody give me a guess as to what data point or what number would be the 80th percentile for this list of data? So I got to vote for what now? 26? I got to vote for 26. Anybody have a different opinion?
Say 80th.
Say again?
What did you say? The 80th.
80th percentile for that list of data. What does that mean should work, should happen? There should be what, where? 80% below the data point.
27.
All right, 27 is a guess. Yes? No. Sorry. Thanks for playing. All right, now listen, guys. Stay with everybody with me? So whoever said this, you do have 20% above. Are you guys cool with that? 2 out of 10 is 20%. Are you guys with me? But how many's below 26? Only 70% below. That can't be P80 then. So what about this guy? It does have 8 below it, right? But how much above it?
Both himself and the.
No, how much above him? 10. You don't count yourself, right? You guys kind of with me? Yes. Beautiful. 26.5. What percentage is below it? 80%. 8 of them. 8 out of 10. What percentage is above 26.5? 20%. 2 out of 10. You guys see what I'm trying to say? A little bit? No. So, here's the thing. You ready? The 2 steps to finding the percentile. I want you to realize I like to do this example because it kind of shows you why I have to adjust, possibly. So if I want to find P80, the first step is to take, let me see if this makes sense. P80 should be the data point that's like 80% of the way in. How many data points do I have? 10. So the first step is to take 80% of 10, which is 8, right? If your answer to the first step is a whole number, you average that with the next one. We just had an example that shows me that's jives with what we did, right? Didn't we average this with the next one? 80% of 10 is 8. But was the 8th point the answer? No. I had to average it with the next one. So the second step would be average the 8th and 9th data points. which is what we did. So if I want to find, let's do another one. If I want to find P16, what's the first step? How far do I want to go? 16% of 10. And why is it 10 for this problem? It's not 10 always, right? I love it when people pick up on the wrong thing. If I had 20 data points, I would do 16% of 20. 16% of 10 is 0.16 times 10, 1.6. Is that a whole number? So when you get now listen, there's only two options here, so don't freak out on me. You do have to memorize some stuff. Whole number, you average that one with the next one. Anything else, you round it up and take that number. What's the second number? 11.
You said you average 8 and 9
Data point, yes. The 8th and the 9th data point.
And then for the second one,
Yes.
what did you do?
I came out with something that wasn't a whole number, so I just round it up. Even if this was 1.1, you would round it up to 2, and that is the answer. The second number is the answer.
No, I mean like what does that say at the bottom? For number 2.
Second number is 11. So, right here?
Oh.
Yeah. So you take the second number. So if this would have came out to 3.3, round up to 4, the fourth number is the answer. It's when it comes out to a whole number, you go, oh shit, I got some work to do. I got to average that with the next one. Yes, sir.
So P16 is 11.
P16 is 11. Now notice this. All right, let me stop right there. So everybody's semi-decent, and we're just barely doing this in like the negative seconds of class. I'm pushing us. P17 is also 11. P18 is also 11. Why is that fine? How many freaking data points do I have? 10. There's got to be repeats. This is why when you have a very small sample, P17, P18, P9, they could all be the same number. There's only so many freaking points to pick from. The minute I have like 100 data points, maybe each one could be its own percentile. Yes?
So when do you know when to average the points?
If it comes out to a whole number, you average that with that. If it comes out to anything else, you round it up, take that number. That is going to have to be a procedure that you memorize. But I did this first to show you why it makes sense. We did it before I even told you to do it, right? We did this before I told you to do it. So it just makes sense. This tries to capture that idea in general. So if I had 37 data points, and I want to find the 27th percentile, I'd take 27% of 37. That's going to come out to a decimal.